It's 3 p.m., so we can start now. Currently, we are in the week 4 of the Introduction to Material Science and Engineering course, and this is the doubt solving session based upon this particular week. Or if you have any doubt throughout the week 1 to the week 4, we can discuss that. Let me give you the brief what and all are, what are the list of the topics that we have covered in this particular week. They are as follows. We discuss about the carbon nanotube. We discuss about the C60 bulk Minster fullerene. Then after that we discuss the various ionic solids, NaCl and ZnS. We also seen what are the critical radius that is required for a particular coordination number to be satisfied, and depending upon that, what kind of crystal it can take. It can take rock salt structure. It can take the CSCl structure. Okay, these are the prototype structure. They are not like CSCl is not the only the crystal structure of the CSCl. Okay, so we are studying. After that, we went through the BCC versus CSCl. So in this also we have saw that cesium chloride. We saw that cesium is sitting at body center, but we are not calling it as a BCC. But then we discussed that it is a lattice that the lattice is not equivalent at the center and at the corner. So we have removed that one. Then we discuss the amorphous solid silica. We discuss its various form like quartz, and we saw its field glass. Then we discussed about the polymer. We went to the thermoplastic and thermoset polymer. We discussed the tacticity. This we have covered. After that, the polymer and copolymers, and then we have discussed about the crystallinity in the polymer. These are the list of the topics that we have covered in this particular week. Week 4. Do you have any doubt in this list of the topic that we have covered till now? If no, then we can move ahead and we can solve the couple of questions. Question number 1. What we have is, what if we try to describe the carbon nanotube? Is it a single diamond structure, a graphene sheet, a form of a mixture of graphene and graphite? We know the answer that it's we will take a graphene and we'll roll it. Okay, and then depending on the now again further classifications are there that we have seen in the class, but the answer for this the carbon from a broader area perspective, D is the one. Alternative wall carbon nanotube. Question number 2. We have to do the matter over here. But the carbon nanotube, we can match it with it was Suzy Izima. It was discovered by the Suzy Izima in the 91. So we know that and we're going to the D. Armchair nanotube. What was the answer for them? For the third one, President. It will match with the dual carbon nanotube. And then we have armchair carbon nanotube, and it will resemble with the like the edge of the carbon nanotube will be like armchair, so it will be something like this, where this can be considered as the arm, and this is chair where a person can sit. So C is going to match with the A, and the fourth one is going to match. So So this is a math pair that we have solved. Let's go to the next part, question number 3. In meanwhile, like whenever you feel some confusion, you can always feel free to ask me. The question is very interesting. What is the crystal structure of the solid C60? Okay, this is something Buckminster Fullerton we have discussed. So C60 is so C60 is made up of the FCC lattice. And then along with that, we have this entire structure on at one particular lattice point, we know that it is 60 carbon atoms that are sitting. Okay. So with that, we have solved this and we got the right answer to the option. Let's move ahead. Only in its structure. Is it a true or false? It is in its structure. The answer for this we can see over here. We have the hexagon. But along with that hexagon, we also have the pentagons. If you stack the hexagon, they will only form the 2D pattern. Okay, but we know it's a buckyball. The structure is like a buckyball, so a pentagon should be there to give it the curve shape. Okay, so C60 contain only hexagon in structure. Answer is no. False. It's a mixture of the pentagons and hexagons. But the structure of the C60 is based upon the truncated icosahedron. This is something which we learned in the class. Like if we take the icosahedron and we cut the entire all of the vertices with the pentagons, then we'll get the truncated icosahedron, which is C60. Okay, so answer here is true. Now, each carbon atom in C60 is bonded to the 3 other carbon atoms. Is it true or false? Like one atom, 3 of the carbon atoms attached with it. The answer is present in the figure itself. What do you think? The right answer for this? Yeah. We can see one of the carbon atom presented with the 1, 2 and 3. Total of the 3 other carbon atoms. This we can say bonding number 1. So see, it's a true. Let's go to the D part. The face-centered cubic structure of C60 means that indivisible carbon atoms sit on the lattice point. Indivisible carbon atoms sit on a lattice point. It's not all the carbon the lattice point. Its answer here will be false. They are associated with the one lattice point. That is true. But if we say all of the carbon atoms are sitting at the lattice point, then it's an incorrect statement. The last part. A pure crystal of C60 consists of molecular arrangement in an FCC lattice. It's a molecular arrangement and the lattice is FCC. And this is true. We know the C60 the Buckminster full ring, it will form the FCC lattice, and at one buckyball will sit. Okay, so this entire molecule is going to sit. So with that, we have solved this, and the answer here is true. Let me write down the on the left side. This is false, true. With that, we have solved this question number 4. Let me know if you face any doubt in this. We can discuss it. Let's go to the next part, question number 5. The Brebel lattice of the graphite is dash and the crystalline Buckminster fullerene is that. Okay. You want to answer. One can get confused a little bit. The lattice of the graphite is it's a at this point. The answer is D. We know we have to be careful. They ask only about the by mistake make the choice the way but it's not okay. And the right answer over here is option D. Let's move ahead. Let's go to the next question. Question number 6. The following is an M comma n, we can represent the carbon nanotube. What we have if M was 0, both the numbers are same. In that case, we will get it. So we classifications, you can answer this question. Which of the following is an armchair? For armchair, we need both the numbers. So here, the right answer will be the A. If we change the question instead of armchair to the Z, what it is option C to be the right answer. These things we can do, and like some easy questions can be asked in the computer based upon this clear concept. Let's go to the next part. The question states that metal exhibit metallic bond, van der Waals bond. Among these 4 types of bonding, which metal exhibit? Metal bonding. And it's not. So it can form coordination number. It will surround itself atoms and it will try to maximize the number of coordination as possible. We study in this particular that we got between the two graphene this 8 coordination of the cation and the anion. Talking about the triangular coordination. The triangular coordination mean like here and over here, it should be sides. And this is critical. This is very critical. Opposite. Right. So RC graph, the ratio should be 0.15. For the critical we are talking about. If it is not fine. If it is less, then they will prefer to be in. Okay. So with that we have solved this part. Next we need that here the coordination was more than the coordination number will be 4. More than this we will get the octahedral coordination 6, and this 7 3 2 will get the cubic coordination 8. So we'll remember this is a very important. Whenever we talk about the these are the like it has to, it is very possible that the number RC by R is more than this 8. Move on to the next part, question number 9. One thing that which coordinate has a critical radius of 0.225. Orthogonal. We have just now studied that it is a tetrahedron. Option A will be the right answer over here. This kind of questions we can expect in the exam of this courses. Okay. Now the next part, question number 10. Let's see if we can solve this. We are talking in the metal, and we know the nature of the bonding in the metal. We don't think it's a metal. And it's usually smaller than the anion size. So right. There are cases if span size is much smaller than let's move on to the next part. See, cation will be bounded by dash to maximize the electrostatic attraction. In stable ionic structure, what the ionic structure? Ionic structure has the cation. Cation prefer to be surrounded by the dash to maximize the electrostatic attraction. We know the answer will be the anion. Cation having the positive charge. If it is surrounded itself by the negative charge, then they cancel out electrostatic. They can reduce their energy. Okay. So with that, this is option C. Let's move ahead. The critical radius ratio for the octahedral coordination is. For the octahedral we know the coordination number will be the 6. Right. So for critical radius ratio, we have in the class that RC by 4. Perfect. So the answer is 0.414. Instead of octahedral, if I uh, cubic one, then it will be 0.7. Let's move to the next part. Is part of the task coordination. We know, we just now discussed. It's cubic. And it's surrounded by the 8 anions. Right. This question number 10. If there is any doubt in this question, let me know. If not, let's move to the next. Now we can quickly we can complete this. The triangular, for the triangular it's 0.155. Very good. And it's not because it's very good. Yeah, it's a C. Point. It's a point D. Very good. Cubic it's a. So with that, I think now the values are there in our head. Let's move ahead. Let's go to question number 12. In the NaCl structure, how many chlorine ion surrounds a single anion? Let's see. Option is the right answer. For the NaCl, they will come out somewhere in between the 0.73 and 0.414. It come in between this, and we know in this the octahedral coordination. So the right is correct. Now this is interesting. The question is not the lattice. NaCl, we know it has a lattice. C. That's great. Perfect. Show the one sodium. And the more is made up of the Na and the position we can write considering the chlorine to form the and sodium take half OO and and we take the central one which is we know that in FCC they are also at the and in this particular lattice which is made by the chlorine, sodium is sitting at the octahedral. So this octahedral it is sitting at the edge, then we'll write as if we are considering the edge like half we are considering for we can write half of it. So any one of this particular thing we can write. Question number 13. Let's move to the next part, question number 14. The radius ratio of the CSCl. The ratio is given to us 0.91. Coordination is expected. Very easy question. The coordination. Okay. Got the same thing. So in the case also, we can consider the chlorine to form the let the and the CS. Chlorine is sitting not principle we have to understand. Not the BCC. It's not BCC. Okay. It's a Let's move ahead to the next part. 15. Now the thing that we have discussed last question. Options are given that bodies and the corners are chemically different. Second, the unit cell does not have the structure followed an FCC arrangement. The coordination number is 6 instead of would be right over here. Why we are not considering PSC here? Even though sitting at the center, instead we are considering them as a simple cubic. That here is the option A. Even though the atom is from the corner, in the center we have CS. This would be chemical with each other. This is the condition. If not, then we consider part of the and then we can call simple cubic as that term will be made up of the which is sitting at the with that we have solved this question number 15. We can move ahead to this part 16. Here. Is a structure. It has the FCC lattice, chloride type structure, rock structure, cubic at the center, and the anion at the now we have discussed. Inside the chlorine to at the corners. They are equivalent with each other. And we can cesium better. With the cation at the center, the anion at the right of 0.8. Body number would typically be predicted. Okay, so this is our question that we have we have the radius ratio of the cation and anion. Okay, Zn and sulfur. and the ratio is 0.48. What will be the predicted one? Okay, which one it is we don't want? What is the predicted one? That this is the question to us, and we can easily solve this with the help of the radius ratio value that we have learned. So what will be the right answer over here? Point 4 and point in between. If RA is this, then the coordination will be the octahedral. So according to that, it should be the option B should be the right. Right. Where the right and tip is made up of, we can write the we can write like 1 by 4, 1 by 2, which is required by the carbon itself. But the latter we can say it's the 1 by 1 by required by the zinc. And the cons or the lattice point of the FCC will be the next part, question number 8. We have the silicate. I think that the solar line melt. Okay. Maybe some network issue. It's fine on my end. Able to hear me? Is it working fine now? Am I audible to you? I'll do one thing. I have to speak more closer to the mic. Maybe if I, yeah, yes sir, but some disturbance. I'll do one thing. If I'm and looking, then speaking, it might be the editor. I'll try to avoid it maximum. Let's go ahead. Saline glass has the low melting point. They have the low melting point. And the silica, the sodium glass, which we are talking. Okay, sorry. I got confused with the fused silica. The answer here is true. Fused, the melting point of fused silica is quite high compared to the melting point of the right. So we can say that the option A for the question. Let's go. Silicate tetrahedra is in form of Thering network. The answer here is about the quartz. The quartz, whether it's amorphous or a crystalline. It's crystalline. That quartz is a form, and so it is the corner sharing networks are there. Okay. So for example, O, O, O. All this oxygen, this unit cell, sorry, this particular tetrahedra will be shared with the tetrahedra in all the directions. And form and the size and they form the crystal. Okay, it's not the amorphous, it's a crystalline. They will have a long periodicity. The answer here is true. Let's go to the next part. In total class, Na2O is network form. They're telling that Na2O will form. What SiO2? It will modify the network. This is not true. Na2 is the modifier, while the network is formed by the silica. Okay, so if we make it around, if we exceed their position, it will be true. Na2 is the modifier and the SiO2 is the network. This false. Okay, so the network will and the network will modify. So the last is the first window. So the glass is used for when the fused silica glass is used for the normal window. This is little tricky question. It is related with the application based. We can leave D the question with the question. So now we have to think that for furnace window, if you are using particular glass for a furnace window, then it should have the high input. A normal window which we use on a daily basis, okay, it doesn't require pressure this much, right? It's just that we have to care about the cost. Think it this way. If we take the soda lime glass, it will easily get, so we cannot do that. And the normal will use the soda lime glass. The answer here is false. We won't use for the window. We need high melting point, which is fused silica. We won't go on window. The melting point can be low. If the melting point is low, and so we can use the sodium glass for the window, while the fused silica glass is the window. So with that, we can like that's false. Around make and it's true. The entire question number 18. Is there any doubt that you have? Let not move ahead to the next part. Question. And move to the part. Very simple. Very simple it is. Crystalline lack short long range. Lack short range but have long range. Have lack long range. both short range and long range. In the small distance, it will be the does it have does it don't have both of them, or it has any one of them and other missing? Or we know when we are talking about the crystalline solids, it has both the short range and the long range order. So with that, D is the right answer here. Okay, so Klein have both short and labor. Now let's change the question from just a crystalline and make it amorphous. Fused silica glass. In that case, we have the short range order. What's missing is the long range order. Long range we don't have. Crystalline amorphous only has a short range order. So with that, we have solved the question 19. Now we can move. If we fail out in this part, feel free to put the comment and also put the question in the Let's move to the next part, question 20. As follow. The crystalline periodic atomic arrangement order, crystalline form silica amorphous. We can say that the first one is matches with the have periodic atomic arrangement B. Let's go to the first solid. Amorphous solid, we know it's a long range translation order, but it has a short range order. See, tetrahedron. Physical tetrahedron, we know it's a basic of the structure. If you're getting the short order, it means that the silicate tetrahedron is following the amorphous. But if you are having a long range order by repeating this particular tetrahedron, you have crystalline quartz. So the one can match with the D. The quartz has silica, that is correct, option E. Fused silica glass and silica structure with the high quartz. So fifth one will be with the F. It has high Na2O glass in if you're adding Na2 silicate glass, it acts like a network modifier. Right? Na2O glass as a network modifier, and it is helping to reduce the melting point. Right. So sixth one, Na2O soda lime glass, we know that it reduces melting point. So option here will be the A. So this is the correct answer for this maze. If you face any doubt in the particular one, let me know. If not, let's move to the next part, number 20. Sorry, 20. A very simple question. The question says the angle between the carbon bond in the tetrahedral structure is approximately. Okay, in the tetrahedral structure. Okay, for example, CH4. We are talking about the carbon is having the hydrogen. Tetrahedral form, and we know in the tetrahedral structure, this angle, we talk about this angles. They all are 109.0 degree. So with that, first we'll have the option C to be the right answer. Let's go to the next question, number 22. Now it's depend upon the now this question is based on the polymer structure. Okay. And it the answer is completely based upon the monomer that we have used. Okay. So for example, we have this, nothing with this particular monomer, and instead of hydrogen, if I replace it with the chlorine, so what I will get vinyl chloride. Okay. So we replace it with the, so A is going to match with first one is going to match with the B. Now the second one. If I replace all of them, the fluorine, so I get polytetrafluoroethylene. So the answer here is C. Based on this particular replace, if I am replacing one hydrogen group and another with this group, I will get PMMA. So third study. Okay. Okay, we have to do over here is chlorine, which I am replacing. So and this will be my monomer. We can call it polytetrate. Fourth one is going to match with the E. Now let's see the polystyrene. If instead of hydrogen, I replace the chlorine, I will get the polytetrate is going to match with the A. B, C, D, E, and A is the right answer over here. Let's solve this question number 22. If any let me, it just based upon the knowledge. Okay. Let's move to start number 20. What are not the characteristics of thermoplast? It doesn't has the cross link. It has can easily be saved. And there is within the two chains we don't have a primary. It is not present between the chain. Like if I'm taking a chain of this particular polymer and another chain, the link between them will not strong. Okay, so primary bond will not there. Let's ask this 23rd. They have the strong cross linking? No, don't have strong cross linking. They and can be remolded. That is right. Thermoplast, we can easily soften them by heat. We cannot do that. Okay, so this right, they can be reshaped one set. This now can be because have the low, like it can because it can be often hit. They have the bond between the chains. We know that it is. They have the second. This is again the, and we need the incorrect statement. The incorrect statement is follow A, C, and D. With that, we have solved question number 23. If there is any doubt in this, let me know. If not, let's move to the question number 24. Very easy. Which we have discussed just now. Polymer chain are held covalent bond, of course, hydrogen bond. We know they are held by a secondary bond. made by the van der Waal. So C is the right answer over here. Okay. So we got to know a lot of things about the cross-linking is not there. They can easily say the primary bonds are not there, only have the secondary bonds, and among that we can say that it's a bond. Okay. And one more important thing, it can easily be saved. C is the right answer. Let's move to the next question, question number 25. If we go to the class, then you can see what the activity refer in a structure. Molecular weight of polymer. Answer is no, it's incorrect. The rate of the spin along the melting point of incorrect. Elasticity of the polymer. No. The arrangement. Let's make PVC. So how the chlorine is arranged? So all the chlorine on one side, or all of them are the on the they are from they are random. This is what the tacticity talk about. Okay. So with that, we all this and we got the answer to B. Great. Let's move on to the next part, question number 26. Further classification of the tacticity. Isotactic polyvinyl chloride. It means that all on side. So we can write the right answer over here. Chlorine and alternate atom are arranged randomly. So here the option is D. Second, it means that they are alternate. If one chlorine, next one will be on the other side. If the chlorine atom alternate on the opposite side, then B the right answer. Third one, it means that they are randomly arranged. So option C will be the right answer. Now it is used to control the tacticity. These are the few basic information that we need to be aware about the polymer. Let's move to the next part, number 27. The question says random copolymer, alternate block copolymer, branch copolymer. We have to match them. Random copolymer. It means that first of all we know that it is made up of the one monomer. Okay. That means that the unit they don't have any fixed pattern. They are repeating without any order. So the monomer without any pattern, it's option C. Alternate polymer. It means that A, like the first monomer, if we refer to as A, second monomer referred to as B, so they are in the alternate type of bond. Monomer sequence. That's option B. Block copolymer means that one block, then it will be followed by the B, again it will be followed by the A, and it will be by the B. Okay, so we can say that the last segment of the one monomer is followed by the another. And branch one polymer, for example, A is forming the backbone, and the polymer B is forming the branching. Okay, so with that, the fourth one, the answer is A. Right. So let's answer. The answer here is B. So the answer is C, B, and then the answer. We solve this question number 27. Let's move to the next part. Question number 28. What is the structure of polymer? They are fully amorphous or they are free. What is the mixture in between the crystalline and amorphous? Some region will be of the amorphous. We- That it can be like this, okay, and so it can be. Okay. So certain region can be amorphous, and the certain region can be crystalline. So it's always a mixture of the crystalline and the amorphous region. So with that, we have solved this question by 28. Okay. So it's the polymer is neither completely crystalline, neither amorphous. No, but it's in the gray zone, somewhere in the crystalline. Let's go to the last question of this particular week, 29. Question number 29. If you have a similar question in the assignment, how to solve them? If the degree of the polytetrafluoroethylene is 400, AMU. Okay. So we know that degree of polymerization. It is given by molecular weight of particular polymer divided by the molecular weight of corresponding one. Degree of polymerization is given to us 400. Now find this. This is our option. We need to find molecular polymer. At the bottom, we have to write the molecular weight of the monomer. What will be the weight of the monomer? The monomer is made of the chlorine itself, carbon, and fluoro. Okay, remaining are repeating. So here given by 2 times of chlorine, of fluorine, so 2 times of carbon, and 4 times of fluorine. This will be the molecular weight. Carbon is given by fluorine is given to us 90. Okay, plus 4 into 90, 76. Now we can find the molecular weight of the polymer. Okay, so that we have solved this question number 29. Just let's do it. 76 plus 24, it will be how much? 80 and 20, it will be 100. So molecular weight of the polymer will be the 400 times 100. Okay, it's the 40,000. And unit is AAM. This is the final answer. This is the molecular weight of. Sorry. Okay. The question, one of the things will be given to us. Either the molecular or the polymer will be given. We have to take the polymerization. Or it's the we have to find the degree of molecular weight of monomer and the degree of pressure. I have solved this question number 29. And I know if a lot of exams are going on. With that, a lot of people getting as soon as separate. What we can do is you go this particular video. If there is any difficulty, if any questions is supplementary, if you did any of the you can write in the comment box or even in the key forum. We can discuss those questions. Along with that, if you see any in the previous week assignments, that also we can discuss. Okay, feel free to the question, and I'm happy to answer in this particular week, and I'll be happy to see all of you in the next week, week 5 dot solving session. The session will be conducted on the same day, Saturday, and 3 to 5 p.m. Okay, see you all. Bye.